All right, so we talked about midlines, amplitudes, and periods, and now we're going to talk about phase shifts and vertical shifts. We kind of talked about vertical shifts in the last video, but don't worry about it. We'll talk about it again, kind of in a different way. So remember, this is our standard form. You can use sine or cosine, but sometimes you might see it in a different way, and there's like some niche differences between them, but it's not super important for us right now. But you might also see sinusoidal functions written in this fashion, where b is factored out. And if you do see it in this way, again, these are the same things, because, right, if we distribute b, we get bx minus c, because the b's cancel in the second one. So they are the same. But this one shows the actual phase shift. Okay. So the phase shift, which I think we were doing in green, is C over B. Okay, and watch out for this negative right here, right? It should be X minus C over B. C over B to the right. So for example, like if we had X minus 3/2, right? C over B is 3/2, so the phase shift is 3/2 to the right. But if we had something like X plus 1/2, right, then C over B is actually negative 1/2. So C over B is the opposite sign of what you see right here, because there's a subtraction sign right there. So it can be a little confusing. You can always double check your answers in Desmos, okay? So phase shift is 1/2 left because it's a negative value here. So watch out for that a little bit. Okay. And then kind of like we've done before, you know, D just is that vertical shift. Very closely related to the midline. So let's look at this a little bit on Desmos. If we pull up our graph, and let's look at, you know, just a regular old sine function. Look at a regular old sine function right here. And I want to shift this pi over 4 units to the right. We can just subtract pi over 4. Now, normally, right, let's compare these graphs right here. Normally, sine starts at 0. But this moves it pi over 4 to the right. See how it used to be here and then it got moved pi over 4 to the right? That's exactly what's going on. You can see it a little bit more if we graph the original function right next to it, right? So the blue graph is just the green graph shifted over pi over 4 units. Every set of pairs, it's just pi over 4 different. Or we could subtract even more, maybe pi over 2. That shifts it even more. We could shift it over an entire pi, and now it's getting shifted further and further to the right. Okay, so let's do some problems here. Example 4, let's utilize this stuff. Example 4 says determine the direction and magnitude of the phase shift. For the following problems. Part A, we have f of x equals the sine of x plus pi over 6 minus 2. So notice, right, in standard form, or general form, it's bx minus c. Here, b is 1. And c is negative pi over 6. Right, because that general form has a subtraction sign right there. So watch out for that. Another thing is you can remember function transformations. Plus on the inside means to the left. Okay. So either way, the phase shift I need to write, let's write lowercase. Phase shift is going to be C over B. So C over B is negative pi over 6 divided by 1, or just negative pi over 6. So pi over 6 to the left because it's negative, or to the left because there's a positive here. However you want to think about it. That's magnitude, and that's direction. And that's exactly what we're supposed to do in these problems. In part B, if we look at f of x equals the cosine of 2x plus 4 plus 1. Again, this is our b value right here. C value, right? C is negative 4. Watch out for that. Then again, the phase shift, just C over B, or negative 4 divided by 2, which simplifies to negative 2. Phase shift of 2 units to the left. You can see these graphically as well, but these ones are a little bit more complicated to see graphically, especially in this one because the period is pi. 2 pi divided by 2. The period is pi, so the period's in terms of pi, but the phase shift is not in terms of pi. The phase shift is in terms of, it's just 2. There's not in terms of pi, so it's a little bit more difficult to visualize that situation. But you still can. So let's summarize. The amplitude, we find that by the absolute value of A. The period was 2 pi divided by B. The phase shift was C over B units to the right. And if it's negative, right, left. If it's negative. And the midline is Y equals D, which is a vertical shift up D. You may be asked about vertical shifts as well. All right, let's utilize all of these. And again, this is for equations of this form, a sine of bx plus c, bx minus c, Jason, plus d. So this is like maybe one of the most important things for this whole section. Let's combine it all in an example problem. Example 5. Find the above, even though I went to the next page, for y equals 3 sine of 1/2 x plus 1. So we'll just go in order. Here's our a value. The amplitude is the positive version of this, which is just 3. This is our b value. Period. Let's go off to the side. P is 2 pi divided by the absolute value of b. So it's going to be 2 pi divided by the absolute value of 1/2. Dividing by 1/2 is the same as multiplying by 2. The period is 4 pi. We're going half the speed that we normally oscillate, so it's going to take twice as long. Twice as long as 4 pi. The phase shift, well, there's no minus c here at all, right? There's no phase shift. And the midline is right here. Midline is y equals positive 1. There's a vertical shift up 1. And that's what we're supposed to do. Let me know if you have any questions, and que tengan buena suerte. Good luck.